Today we're going to be talking about trigonometry, and we're going to be focusing on the inverse trig functions. So yesterday's video, lesson A, focused on just a regular trig function. Today we're focusing on inverse trig functions. Okay. So the first thing is, remember to set your mode to degrees. And again, I went over that in yesterday's video in depth, how to do that on both your calculator and your cell phone to make sure that you're in the right mode. If you and your friend are getting different answers for the same problem in your life, I typed in exactly the same thing, remember it means that one of you is probably in the wrong mode. We want it to be in degrees. Okay? So today we're going to have the inverse trig functions of the same functions we talked about yesterday. So just as a reminder about yesterday, we talked about sine, cosine, and tangent. And we said if you were given an angle and one side, then you could use our trig functions, sine, cosine, and tangent, to be able to find the third side. So we're going to go back through one of those. So in this one, we said, okay, we have this 70-degree angle, and this side here is an adjacent side. So we put a check mark beside each of the A's in our SOHCAHTOA. And then this is the hypotenuse because it is across from the right angle. And so we're going to put a check mark by each of the H's. And whichever trig function gets two check marks, in this case cosine, that's the one that we are going to use for our problem. So we said we would write down cosine of 70 equals 15 over x. Okay? And we said that in order to solve this, we have a couple of steps. So the first step is going to be, we multiply by x on both sides, and that's going to cancel out these two x's. So my new equation at this point says x times the cosine of 70 equals 15. Well, I'm trying to solve for x. These two on this side are multiplied times each other, so I want to do the opposite. I want to divide. So I'm going to divide by the cosine of 70. Okay? And those two will cancel out, and so on the left I'm just left with x, and on the right I have 15 divided by the cosine of 70. And we said at this point you can type that into your calculator, and you can then get the answer to 15 divided by the cosine of 70 is 43.9 degrees. Not degrees, sorry, units. Okay. So if all these were in centimeters, then this would be in centimeters. If they're all in inches, it'd be inches, so on and so forth. So this is the missing side measurement, is 43.9. Okay. Well, what if instead of being given one side and one of the acute angles on this right triangle, what if instead we had been given two sides and we wanted to know what is the angle here? Okay, can we use our trig functions to help us find that? And the answer is going to be yes. We're going to be using our inverse trig functions to be able to find this missing angle. Okay, so first of all, let's go ahead and use our SOHCAHTOA to set up our equation, just like we would have done yesterday. So we write out SOHCAHTOA, and we say, okay, if we're using angle A, we have our opposite side, put checks by the O's, and we have our adjacent side. Okay, so we put checks by the A's. The one with two check marks in this case is tangent, and so that's what we're going to use. So we have tangent of angle A, so we just put an A there, would be equal to opposite over adjacent, so 6 over 20. And the first thing I want you to actually do is go ahead and divide 6 by 20. Okay, so we're going to get a decimal. In this case, that decimal is 0.3. So we have the tangent of angle A is 0.3. And this decimal here is going to be really important. So at this point, we want to take that decimal, and we want to take the inverse trig function. So I'm going to flip over to our calculator, and we're going to talk about how to do that. So when we want to type in our inverse trig function, we have to hit the second button first, and then we want to hit whichever trig function we want the inverse of. And you're going to notice that right above each of these, sine, cosine, and tangent, they have sine, cosine, and tangent, but with a -1 for the exponent. That means that's the inverse. So in this case, we are interested in this button here because we want the inverse tangent. All right? So if you hit second, inverse tangent, and then we are going to actually put in, so it says inverse tangent, we want to type in the parentheses that decimal that we just got. Okay? Has to go in this spot. And this is going to give us the measurement of angle A. Okay? So when we type that in, we get the measurement of angle A then is equal to 16.7. And we're just rounding that to the nearest tenth in this case, so it's really 16.699. But so that just rounds up to 16.7, so the nearest tenth. All right? And so that means that this angle here is 16.7, almost 17 degrees for this one angle. All right? So let's see if we can try another example. Okay, so this time we want to find angle C. This is the one we're looking for. So again, we start off with SOHCAHTOA, superfunduing, and we're going to look at what we've been given. So first of all, we have our hypotenuse. Go check by each of the H's. Second of all, we have our adjacent side here. It touches that angle C, so we're going to put a check by each of the A's. And in this case, cosine is the trig function that we have. Okay, so the cosine of angle C is equal to the adjacent, which was 3, over the hypotenuse, which is 15. So again, we're going to go ahead and divide 3 divided by 15. And so we find out that the cosine of angle C is 0.2. All right? And so we're really interested, again, in this measurement right here. So we're going to take our inverse cosine. So we're going to take cosine -1, so that's second cosine. And in the parentheses, we are going to type in 0.2 because that was what we got for our decimal there. And again, this is going to give us the measurement of angle C. Okay. So we type in second cosine 0.2, and in the parentheses, we put 0.2, and so we find out that this angle's measurement to the nearest tenth is 78.5. Okay. And that is the measurement of angle C. And that's going to be your answer. So I really hope that this helps explain it, and we will look at some other examples in class tomorrow. Remember that your inverse trig functions are to help you find angles. Your original trig functions are to help you find missing sides. That's going to be really helpful, and it's going to be on your quiz. So you want to make sure you get that. Anyway, I appreciate you watching. I hope you have a good afternoon. Goodbye.